Alright, so this is the third video on Simpson's 3/8 rule, and in this video we are going to be evaluating the integral from 2 to 5 of log x to base 10 dx. But before we go into this question, let me take some time to explain the Simpson's 3/8 formula, right? So the formula simply states integral from a to b of f of x dx is equal to 3h all over 8. Now, where h is actually the interval, h is the interval, and it's given mathematically as b minus a all over n, and n itself is called the subinterval. Okay, n is called the subinterval, and it is this subinterval that determines the nature of the formula. So if you take a look at this formula, you have 3h over 8 multiplying f of x naught plus 3f of x1 plus 3f of x2 plus 2f of x 3 plus 3f and so on, right? So basically what the formula is simply saying is the first function and the last function are without a multiple of any value, so they stand on their own. So I have f of x naught standing, and then f of xn, which is the last function, also standing. But if you take a look at the formulas in between, the functions in between, you see that after the first function f of x1 and f of x2 have been multiplied individually by 3, the next function, which is x3 now, is multiplied by 2. Then the next two functions is multiplied by 3, and then the next function is multiplied by 2, and so on. Now you can encounter this lengthy equation by your subinterval. So the essence or the idea of the 3/8 rule is to make use of a subinterval that is a multiple of 3. So you can start that, so it starts from 3, 6, 9, and so on. So if you choose your n to be equal to 6, it means you're going to be having this lengthy equation. If you choose your n to be equal to 9, you also have more lengthier equation. But if you choose your n to be equal to 3, then the equation is actually what? Limited. So the understanding I want you to get here is that the first function and the last function are not multiplied by any value. Then the function in between are interchanged after the multiple of 3 into 2, and then by 2, then the next multiple of 3, and so on, right? So for this question, we are going to choose n to be equal to 3, because when n is 3, the formula is actually what? Shortened, and it makes the equation easier for it to be solved, right? So we're going to be considering n, which is the subinterval, to be equal to 3 for this particular question. N is equal to 3, and from here, if you compare this to this, you find out that the lower limit a is equal to 2, and the upper limit b is actually equal to 5. So with this, you can find your interval h. The h now becomes b minus a, which is actually 5 minus 2 divided by n is equal to 3. So 5 minus 2 is 3. 3 divided by 3 simply gives us what? So our interval is 1. So what we need to do now is split this limit from 2 to 5 into 3 subintervals. That's why we choose n to be equal to 3. So we split them into 3 subintervals. So let's simply make a table to put in our values. Okay, we make a table here. So these are the values of x. So x naught represents the lower limit, which in this case is 2. Okay, so these are the values of the function at each of those points. So x naught is the lower limit, which is 2. We find next x1. Now x1, so let's start by x naught equals 2. x1 is going to be x naught plus h. So the value of x naught is 2. Our h is actually what? 3. Sorry, our h is 1. So 2 plus 1 equals 3. So our x1 is equal to 3. So x1 equals 3. Next, we find x2. x2 becomes now x1 plus h. This is going to be equal to x1 there is 3 plus h is 1, and that's equal to 4. So our x2 is actually 4. And our x3 is going to be equal to x3 equals x2 plus h, which is 4 plus h is 1, and that gives us 5. So you see, our x3 is equal to 5. So once the limit has been spread between 2 and 5, you stop. So we've gotten our x3 to be what? 5. It means now that we have split this limit from 2 to 5 into 3 subintervals, where x0 to x1 is the first subinterval, x1 to x2 is the second subinterval, and x2 to x3 is actually the third sub-interval, and that's settles it. So once it gets to the upper limit, you stop. Now, having this, the next thing to do from the formula, if you're observing the formula, you find f of x naught, f of x1. So which means we need to find the value of the function at each of those points, right? Okay, so we start with f of x1. Let's do that here. So f of x1 is going to be equal to the value of the function, not forgetting our function f of x itself is actually log x to base 10 and not to base e. Please, log x to base 10. Okay, so x now becomes x1. Wherever you see x in this equation, simply plug in the value of x1. x1 itself is 2, so that gives us log 2 to base 10. So let's simply find log 2 to base 10. That gives us 0.3010. So you have 0.3010. So our function there, the first function is 0.3010. Next we find f of x1, and that's equal to log x1 is 3. So it becomes log 3 to base 10. And this is going to be, let's find log 3 to base 10. Log 3 to base 10, that gives us 0.4771. We have 0.4771. Next, we find f of x2, and that's simply log x2 is 4. So you have log 4 to base 10. This is going to be, let's find log 4. Log 4 is actually 0.6021 approximately. So we have 0.6021, okay? This is 0.4771, 0.6021. And finally, we find f of x3. This is going to be log 5 to base 10. And that value gives us, log 5 is 0.6990 approximately. We have 0.6990, okay? 0.699. All right, so having found the values of the function at each of these points, let's now compute into the formula and solve, right? So see the uniqueness of choosing your interval to be equal to 3. The integral from 2 to 5 of log x to base 10, the x is going to be equal to, using the Simpson's 3/8 rule, you have 3h over 8 into, so remember the formula, the first function is not multiplied by any value, right? So I have f of x naught. The next two functions I multiply by 3, right? So plus 3 fx1 plus 3 fx2. After that, the next function is supposed to be multiplied by 2, but that is x3. So the function now x3 is actually at the very last, is actually our last function, right? The function at x3 is actually our last function. So for that reason, the last function is kept like that without any multiplying it to any value, right? So you simply keep it as what? Plus f of x3. And this is the uniqueness of choosing your subinterval n to be equal to 3. You see how it has shortened this entire formula into this single thing you have here, right? So that is why it is always advised, except otherwise stated, it is always advised to choose your subintervals n to be equal to 3. Now let's simply plug in our values into the equation. The integral from 2 to 5 of log 10 x dx is going to be 3 times h. Our h is actually 1. So 3 times 1 all over 8 into f of x naught. F of x naught here simply gave us 0.3010. We have 0.3010 plus 3 f of x1. F of x1 gave us 0.4771. So 0.4771 plus 3 f of x2. F of x2 gave us 0.6021. 0.6021 plus f of x3, and f of x3 gave us 0.6990. You have 0.6990. Okay, there you go. So integral integral from 2 to 5 of log 10x dx is going to be 3 times 1 over 8 remains 3 over 8 multiplies. Now I will evaluate everything in the bracket, so do well to point along with me to avoid calculation errors. So everything in the bracket gives us 4.2376. 4.2376, and if you multiply by 3 over 8, you're going to have times 3 divided by 8, so you have that to be 1.5891, 1.5891, and this becomes the integral of log x to base 10 the x using Simpson's 3/8 rule. Alright guys, so that's how to employ the Simpson's 3/8 rule. In the next video, we're going to be looking at Simpson's 1/3 rule in numerical method. I'm sure you want to be a part of that video, so do well to tap the subscribe button right now and turn on your bell notification so you don't miss out on that video when it drops. I will see you in the next video. Cheers.